Welcome to FRC Data Logging and Visualization, Why and How. Thank you all so much for coming. We're going to introduce ourselves in just a moment. I just want to quickly explain how things are going to work today. So we'll be presenting for about 35-40 minutes on logging and data visualization. At the end of that, we'll have a little bit of time for questions, followed by a short break. And then at the top of the hour at 11 o'clock, we're going to switch to our second conference on log replay and simulation. And that's right here in the same room. So to introduce ourselves, my name is Jonah. I am a software mentor on team 6328, and I'm also a core developer for WPI Lab. And I'm joined by...
My name is Neil. I am a junior on 6328. I'm a fourth year software student. And my second favorite color is yellow.
Yes. So let's get started. Okay, so here's the stuff we're going to be talking about today. First, the levels of logging in FRC and how to get started with logging. We'll talk about what is AdvantageScope and a few case studies exploring how to use it. We'll talk about merging data sources. And I want to note too, for anyone who might have seen this presentation before, we have a whole bunch of new case studies and examples that we've woven in, so there should be some new and interesting stuff. And at the end, we're going to finish by talking about some new features in AdvantageScope, both in 2025 and what might be coming down the pipeline in the future.
Cool. So to get started, first we should talk about what simulation and data logging can actually mean in FRC. So the way that we've broken it down is into three categories, which are driver station logging, onboard logging, and log replay. So in detail, the first one we call level 1 driver station logging. This is just built into the FRC driver station. It's automatically set up for you. And we can record simple stuff such as battery voltage, current draw, network diagnostics, and console text that you may print out in your code. And this is good for simple issues and like field diagnostics when you're first debugging the robot, just getting it to run. But unfortunately, since it is level 1 and it's all set up for all teams, it's really general and it's not personalized to what your team needs. So level 2 is a little bit more advanced. This is stuff that you might be recording data to a USB drive on your robot, either through network streaming. You can also visualize the data as it runs through the robot live. And there are a few options for this. You can use WPI Lib with robot code logging, which I'm sure you guys are familiar with. There's CTRE signal logging, as well as rev logging, which is more unofficial. That's also developed by the team. And this is much more customizable than level 1 driver station logging, since you can log what you want in the robot code, and it's set up the way you want it. However, if you have some fields that you didn't log in the first time, there's no way to get that back. And the fields that you didn't actually log during the match or whenever the robot's running aren't attainable after the fact. So we're going to get into level 3 logging, which is a more advanced form of logging. We won't talk in this presentation, but in our second conference, we'll be talking about AdvantageKit and how you may be able to move up a step in logging.
Yeah, so now that we've dived into broadly what logging can look like in FRC, let's look at some specifics. So first of all, I'll say if you're just using driver station logging right now, I cannot recommend highly enough that you explore some of the options here for level 2 logging. They're really easy to get started with, and remember that this includes both producing log files, but also just being able to visualize what the robot is doing live over the network. There are tons of options available for level 2 logging, and we'll have more links to more information about all of these at the end of the presentation too. Okay, so our first category of tools are those that are built right into WPI Lib. And this is useful for logging data directly from your robot code. That might be things like joystick input, odometry pose, subsystem state, etc. Now, WPI Lib's standard protocol for publishing data to the network is called network tables. You've probably used it before. And the data log manager class, which is also built in, will capture all of that network tables traffic to a log file with no additional setup. It's the easiest way by far to get started with robot code logging. You can see on the right, we just need 3 lines in robot init to start up data log manager and epilogue, which is another WPI Lib tool. And we're also going to capture the driver station data, like the robot state and joystick inputs. We can then just publish anything we want to network tables like normal, for example, using the Smart Dashboard API, which you can see, and all of that will be captured to the log file. WPI Lib new this year also includes a library called Epilogue, which is annotation-based logging. So you can see we have the @logged annotation on this class, And a method like getValue will automatically be logged every loop cycle. You can check the docs for details on how that works. But all of these tools support a whole bunch of different data types that you can take advantage of, from primitives and arrays all the way up to more complex types like geometry objects. There's a lot of flexibility. Now, there are also several options for logging data directly from vendor devices. CTRE includes what they call a signal logger for Phoenix. It automatically captures data from some of their devices to the Rio. That would include the Talon FX, Pigeon, and CanCoder. It's really easy to set up too. You can see here in Java. And if you don't add these two lines, the signal logger is also started automatically whenever you're connected to the field. However, we would highly recommend starting it explicitly, like you see here, because that way the behavior is identical on and off the field. Teams have actually reported issues with the default behavior, so I'd be careful with that. I also want to note with the signal logger that to access the vast majority of signals, you do need a Phoenix Pro subscription, so keep that in mind. However, CTRE also includes what they call the diagnostic server, and this allows you to stream any signal from their devices over the network, and that one is totally free to use with their products, so definitely take advantage of that one. Now, Rev, on the other hand, doesn't include an official logging option for their devices. We have developed an unofficial alternative, which we call Urkel, the unofficial Rev-compatible logger. And again, it's just a couple of lines to set up. It automatically captures data from any Spark Maxes or Spark Flexes on your CAN bus, very similar to CTRE's logger. All that data is sent to network tables for live viewing, and it can be captured using Data Log Manager, just like anything you recorded manually. And of course, Urkel is free and open source. Okay.
So how do we actually visualize all this data that we're logging through any of these levels? So we have several options. Of course, the one that we're going to talk about is the one that the team has developed, which is AdvantageScope. This is developed in 2021 by our team, and it's now included in the WPI lib installer. So if you have a running robot with software, it's probably already installed on the computer that you use. So this is what we call the programmer's tool for data visualization. We have a bunch of types of levels of logging that are supported by the app, including driver station logs, network tables, WPI lib logs, CTRE logs and diagnostics, Advantage Kit logs. And all this stuff can be viewed using network streaming and log viewing, but it's all condensed into one application. And so we also have a number of visualization tools that you may utilize, including all the ones that are listed here. There are basic views such as line graphs and tables, as well as more complex views such as the 3D field to visualize the robot on the field as it's moving, as well as the joystick view to see the joysticks as the driver's operating the stuff. A swerve diagram to show the velocities and the headings of all the swerve modules on the drivetrain, and other helpful things that you may find useful. So it can be pretty easy to get started with AdvantageScope. It's already included in WPI lib, as I mentioned. You probably already have it installed. If you go to Start Tool in VS Code and choose AdvantageScope, you can find it here. Otherwise, you can just download it directly from GitHub. And we also support other platforms, and you can also add your own robot in order to visualize it. We also have a bunch of documentation online. You can click the book icon on the app to visualize or to see it. And on this documentation, we include stuff such as how to interact with different data sources, how to use each visualization, as well as how to import custom assets to personalize it for your robot.
Okay, so now we're going to take a look at a couple of case studies to hopefully paint a better picture of how AdvantageScope and logging can be helpful. And the first case we're going to look at is one where we're tuning an arm. So for context, this is our 2023 robot. It's called Banana Split. You can see it consists of a triple jointed arm, so there's a shoulder, elbow, and wrist. All of those arm joints are controlled by a feed-forward model and a PID controller, and of course those all need to be tuned. So let's take a look at how we can analyze that arm behavior in AdvantageScope. What you see here is a log file from one of our 2023 events. What I'm going to do here is just drag out the measured and set point angles for the elbow joint. So there's the measured and here's the set point. We can then zoom in to get a better look at the match. And you can see when the robot is enabled on the bottom. Now, we were logging these values in radians, which are useful for the robot but are less intuitive. So AdvantageScope can convert them to degrees, so it's easier to understand what's happening. And we can see here, looking at those two lines, that the angle tracks pretty well, but it's kind of tough to visualize what the robot is actually doing here. So we can also try logging the state of the arm using a mechanism 2D object. Mechanism 2D is built into WPILib, so you might already be familiar with it. And using AdvantageScope, we can view that mechanism 2D data from a log file. So here, you'll see we can just open up a new tab for a mechanism, and then drag out the set point and measured angles, and then replay the match in real time. So here we can see a simple visualization of what the arm on the robot was doing at the time. That's more useful for debugging, but this is still a little bit abstract. It's kind of hard to understand what's going on. So how can we address that, Neil?
So the way we address this is we can switch to another AdvantageScope view, which is the 3D field, where we can see our robot, all the mechanisms on it, and how they move either in log or in live time. So AdvantageScope actually allows you to import the robot CAD from your team onto the app for visualization. And here we can see the same data running on the robot, except we have the robot model combined with all the odometry data, and we can visualize it as it moves around the 2023 field. And this obviously just makes it easier to visualize what's going on with the robot, how it's interacting with the game pieces, the field, etc. AdvantageScope can also connect using network tables, so we can see this data live during, for example, a drive practice or a practice match. One other visualization of this data is that we can create a histogram and other statistics views such as this. AdvantageScope will automatically calculate the absolute error based on all the measurements between the set point and the live recording of the motor encoder or whatever you're using. And here's the average error for our 2023 arm for the elbow across the entire match. You see that the mean is around 0.025 radians or 1.4 degrees, which is pretty good, and as well as the 99th percentile of error being around 7 degrees or 0.121 radians. But let's say we're still not satisfied with our tuning, and we want to increase our performance by retuning the controllers. So the robot project was set up to accept PID gains over network tables, and we can connect to the robot using AdvantageScope and easily adjust gains on the fly using the app. So here we can click the sliders button to enter the tuning mode, and we're running an auto routine just to move between the different positions so we can see how it's tracking. Here we're plotting the wrist measured and set point positions. As we change the KP, we can see how the max acceleration and how the robot responds in real time as we're connected with network tables. We can also use other techniques like this to tweak the code live during driver practice. For example, we might adjust the flywheel speeds up and down for something like a game like Crescendo. And this is just a great way to see the effects of how your software is affecting the robot in live time as well as in an app being simulated just for you.
Okay, so for our next case study, we're going to take a look at vision processing. So this is an area where good logging is really critical for diagnosing issues because it's hard to understand what's going on in the robot's brain without being able to see more details. Now for context, 6328 uses a custom AprilTag tracking system. The goals are basically the same as Limelight and Photon Vision though. We're trying to estimate the position of the robot on the field using all of the visible AprilTags. And this example is going to be from our 2025 robot. Now here we've switched to a bird's eye view of the field. And I'm just going to drag out the fields for the list of visible tags and the individual robot pose estimates. So on this visualization, the green lines are showing which tags the robot can see, and the translucent robots show the individual pose estimates that are being returned. We can even run faster than real time, so you can see here. And then if something went wrong, you can understand this might allow us to track down the problem much more quickly than if we were trying to guess at what the pipeline was doing. And again, we can view all of this data live over the network, so we can create more realistic conditions in our shop with the driver actually driving around like they would in a match. We don't even need to stick to that bird's eye view. AdvantageScope allows us to recreate the video from each of the cameras based on the robot's position. So we can see when tags should be in view of each camera. And in this case, we're comparing on the left the AdvantageScope recreation versus the actual video that we record from our cameras. And you can see they match up very well, which means that even if you aren't recording video, AdvantageScope provides a very good proxy to understand what the visibility of the cameras are as you're driving around the field. And here's one more visualization of that localization data. We can take a log file and create a heat map of the robot's movements throughout the match. So this is really useful both for analyzing the accuracy of our localization data and for just doing match review with the drivers to understand how they were moving around the field.
Yeah. So AdvantageScope can also visualize the game pieces as the robot interacts with them in 3D, and obviously this has a bunch of applications for visualizing how the robot may interact with them during a match or during driver's practice. So here we can see our team used this feature in our 2025 robot. There are a few things to analyze here. We were tracking the state of the reef throughout the entire match, so the robot knows where it's allowed to score on the reef at all times. And of course, AdvantageScope is just providing more of an intuitive way to visualize it. As you can see, some of the branches are filled with coral, and we know the robot knows that it can't score there. It doesn't want to extend the elevator to that point. You can also see the coral and the algae inside of the robot, and this is just indicating whether the robot knows it's holding one of the game pieces, either a coral or an algae, and this is just an easy way to visualize the true or false Boolean on the robot and just make sure it's working correctly. It can also be, it's a simple way, it's a simple implementation. As 2024, this is visualizing the note in the kitbot. And all we have to do is publish a single post from the periodic method of our indexer to show where the note is at all times. And for example, we might implement how the robot knows whether it has a game piece by just using whether a proximity sensor is tripped or not. Many teams this year are also trying to track game pieces around the robot. AdvantageScope can help you with this by visualizing where the robot thinks the algae is or the coral is on the floor. And here's an example when we were prototyping our algae localization earlier this year. And the feature we were visualizing here was that the coral and the algae could be shown around the game, or around the field, from the perspective of our camera. Game pieces are also extremely helpful in simulation, like visualizing autoroutines. And these are examples from 2022 to 2024, where we're just using a simple animation to show whether the game piece has been taken, whether it's in the robot, and whether it's been shot, and to kind of estimate the trajectories of all these game pieces.
Okay, so those couple of case studies were really talking about what we can do with AdvantageScope. But we're going to go in a slightly different direction here, because AdvantageScope is not the only tool available for analyzing log data. System identification is a really powerful tool that's built right into WPILib. Now, broadly, system identification is the process of determining a mathematical model for the behavior of a system through statistical analysis of its inputs and outputs. Inputs is referring to things like voltage or current that you apply to a motor, and the outputs are things like position and velocity of the mechanism it's attached to. And system identification is trying to relate those two things mathematically. So a really common example is that given a desired velocity and acceleration, we might want to calculate what voltage to apply to a subsystem to achieve the desired state. That's called a feed-forward model, and it's useful for all kinds of mechanisms, drives, flywheels, arms, etc. Now we said that's a mathematical model, so here's what that might look like. Here we're converting velocity and acceleration into voltage using three gains, Ks, Kv, and Ka. Ks is constant, that accounts for static friction, and Kv and Ka are respectively converting velocity and acceleration into voltages. The WPILib docs go more in depth about how that works if you're curious about the details. But we can extend this model and use more complicated equations to model more complex mechanisms. But the question then is, how do we determine those gains? Well, you can model that theoretically, but that often works poorly in practice because friction on mechanisms is very unpredictable. So instead, what we can do is measure those gains using log data. WPILib has tools built in to do that. It gathers data over a series of 4 routines. The first step is to configure it all in code. And all of this stuff would go in your subsystem class. So we have to define a setter for our voltage and getters for the voltage, position, and velocity. And then we can produce these 4 tests, which are typically written as commands. It's also possible to do this using CTRE or rev logging directly, like we talked about earlier, and you can consult the relevant documentation for how to do that. So now we just run these 4 tests in Autonomous. These are measuring how the voltage affects the velocity and acceleration of the drivetrain in this case. So what you're seeing here is a quasi-static test. This is measuring how the voltage affects the velocity by slowly ramping it up. We do that forward and backward, and followed by a dynamic test that measures how the robot accelerates when running at a constant voltage. This is applicable to all kinds of other mechanisms, including swerve and flywheels and arms, etc. Now, using that callback we defined, all of the data about the state of the mechanism is saved to a log file. We can browse that in AdvantageScope here. Along the bottom is the test state, so which of the 4 tests we were running. And we're looking right now at the position of a swerve module during each of these 4 tests. We slowly ramp up during the quasi-static test and accelerate more quickly during the dynamic. Now, the final step is analysis. This is calculating the actual values of Ks, Kv, and Ka based on all that data. What we're going to do is open up WPILib SysId Analyzer, grab our log file from the robot, and then we just have to select the fields for the test state, the velocity, position, and the voltage data. We also are going to, in a moment, select the mechanism type and the units, and then we just click the button to run the analysis. There we go, and right here you can see are the calculated feed-forward gains based on our data. And you can see there's actually a lot of stuff that this tool produces, graphs and feedback gains and all kinds of fun stuff. So again, I would encourage you to check the documentation if you're curious about any of that. Now, after we apply those new gains from SysId, we can check the performance in AdvantageScope, and in this case for a swerve drive. So when tuning a swerve, AdvantageScope has this useful built-in visualization showing the states, the measured and the set point states of each of our swerve modules. So we can see that it's tracking pretty nicely. On the left is our measured velocity, which is tracking our set point quite well. So our system identification using log data was a success.
We can also talk about merging a bunch of data sources to make sure that we get data from multiple things and we can visualize them all through the app. So there are lots of potential sources of data that we might be interested in merging. For example, you might have log files of different forms from WPILib, from the driver station, from CTRE or another vendor. You might have external data sources such as match videos or Zebra Motion Works to visualize where the robot is on the field. All of these sources need to be loaded and synchronized, and we can do this through AdvantageScope. AdvantageScope can merge all this data through all of these formats automatically without any manual work to synchronize all of the log and all of the videos. So here we're going to use this in order to utilize some match strategy and match analysis of what happened in one of our matches in 2022. So we're going to merge a match video with some of our log data, and this can be really important because when things go wrong, it's nice to be able to look back and see what could have been improved by looking at the log as well as the video. So here we have a log file, but we want to see exactly what the robot was doing, which we can use using match videos that are uploaded to TBA. So we can synchronize the log. On the video tab, we'll click the TBA icon, and the correct match will be fetched automatically, and the video download will start. And once enough of the match is loaded, it'll automatically be synced to the log with an accuracy of ±1 frame. And no manual work is required, it's all automatic, so the human did not have to change where the video is starting from. Now that we have the video, we can open the other useful view, which is the joystick view. This shows the state of the joysticks during the match as the driver moves them, presses buttons, and all. And joystick data can be logged automatically using WPILib, and we can see as the match plays, we're down at the bottom, and we're going to come flying in a second. But as the match plays, we can see what the drivers are doing moment to moment, and this allows us to distinguish between what code problems are happening and what new drivers might be having errors in some of the human input. So this is a specific time in the match, and we're going to play it at 1/4 speed just to make sure that we can clearly see what happens. So as we're racing back to the hangar, we're at the bottom in the red, and we reach the cable bump, and immediately the driver releases the left joystick, which is in charge of where we're driving, as we go over the cable bump and we just topple. That's because of our inertia, and since we're not following through, we kind of fall on the cable bump. And after a moment like this on the match, or on the field, coming back to the pits and being like, what went wrong, it can be really helpful to see what we did in order to not make the same mistake again in the future. So here we just used log data, synchronized it with the video, and we saw what the joystick was doing at that time. We saw, of course, the joystick was let go, and we told the driver, just please keep on going when you're going over the cable bump, and he never made the mistake again. So this shows that logging isn't only for programmers, but it can be for the whole drive team, so the whole team can improve. We can also merge the same data source across multiple matches. So here we have we're going to merge logs from our playoff matches in 2024. We can select multiple log files when we're selecting what we want to visualize in AdvantageScope. And as soon as it loads, we're going to find the enabled field, and we're going to automatically merge it so we can see all of these robots. So this is across multiple matches, of course. This is during autonomous period. You can see this is one of our earlier events, so we only had one path. And you can see the tracking is fairly consistent. And as soon as we get into teleop, you can see all of our paths start to kind of branch off. This is a fast forward, of course, and we're just all over the place. So it can be cool, this is one of our earlier events, to go back and be like, how has our driving improved over the season? So this is our second 2024 event. And here, of course, we have more variety in our autos. You can see we're taking some more center line as well as some of the out front notes. And we have multiple paths, of course. The tracking is still looking pretty good. And as soon as we get into teleop, you can see that we have a lot more of a straightforward and stick to the plan movement during teleop. So here you can see, instead of branching out everywhere, we're just going to our human player station and going back to the speaker. And you can see our match trajectories are just all in one line on one side of the field. And that's just kind of shows how our driver has improved over time. Again, logs aren't just useful for programmers, it can be for the whole drive team. And here's another example. A lot of teams have struggled with loop cycle times and loop overruns. So there's a lot of potential causes for loop overruns, so it can be nice to narrow it down to what's actually causing it. And it can be inconsistent, but others can be recreated by mirroring the same conditions. One way to track down what's happening is that we can correlate all of our data through all these matches by synchronizing them all and putting them all in one view. And here are the loop cycle times for our team synchronized. And you can see that all of the loop overruns happen during the start of the match during autonomous period. This suggests that something's going wrong at the start of auto. And what we found by comparing our data with other teams was that we found that there was something wrong with one of our vendor deps, and it was an issue that we worked out with other teams because we knew we could point to this and be like, something's wrong right here. We could show other teams, and they could relate if they had had the same problem.
Okay. So we're always working on new features for AdvantageScope, ways we can make it better. And the general timeline here is that we release a beta version of AdvantageScope every fall, so teams can try out the new features, and then we have a final stable version that we release at kickoff. So let's take a look back quickly at what we added this year and where we're going next. So here, these are some of the new features that are new in AdvantageScope in 2025. A few of the highlights. So we redesigned a good part of the interface from the ground up in order to make the visualization controls more clear, consistent between tabs, and more capable. So you'll find on almost every tab, if you used AdvantageScope in 2024, that there are now new visualization options and object types for nearly every tab. We also, by popular request, improved timeline navigation. So for example, in the 3D field, you can zoom in and get a better look at small parts of your timeline. Really useful for analyzing those short stretches of time where something went wrong. And also, a big favorite we've heard from users is that in 2025, opening log files is about 100 times faster than previous versions. So I know a lot of people who are used to waiting several minutes for log files to open in AdvantageScope appreciated that change. Now, we also in 2025 released a new feature which we first teased exactly 1 year ago at this very conference. And it is now released. You can now use it. So we're going to take a look at that. And that's AdvantageScope XR. So AdvantageScope XR enables 3D visualization of your data using augmented reality. So you can view robot models either in full scale, or you can visualize a miniature version of the whole field. So what we're going to go to now is we're actually going to try a quick live demo of AdvantageScope XR. So over here, you can see we're running this on an iPad right now. So hello, everyone. So Neil's going to come around here. All right, Neil. Yeah, so here we've got AdvantageScope running. This is a log file from one of our matches earlier at this event. I'm just going to click this XR button down here. And we've got a QR code, which Neil has now scanned, and it'll connect over the network. So now what Neil is going to do is just select 2 points on the floor, in order to create a miniature field model right here in front of us. So right there, so you can see the robot moving around in 3D space. We can do this, as I said before, either in miniature like this or in full scale, so we can do a one-to-one recreation. Now, one of the questions that we have received about this from perhaps the more cynical people in the room is, why is this helpful over the existing 3D field view? Well, in our experience, one of the biggest challenges that we've had with doing robot simulation, which we'll talk about in the next conference, is keeping students engaged in it. That working with a physical robot is just much easier for students to get involved in and feel like and feel the impact of the work they're doing. And particularly for beginners, we found that when we first introduced the 3D field for AdvantageScope, it was a big difference compared to just watching a robot move around in 2D. It felt much more real. And we feel like this is a logical extension of that. Because a student, even a beginner student, in week 1 or 2 of build season, can put together a simulation of an auto routine and then watch it play out on a real field, possibly with real field elements, which we think is a really cool opportunity to get students engaged, even before a robot is created at all. Yeah. So there we can see, recreating our log. Okay, let's move on.
So here's some other use cases of AdvantageScope XR. This is us simulating our auto routine within our shop at a one-to-one scale. This is, of course, a model of our robot in 2024. And since our shop doesn't have space for a whole field, we can actually see it live without breaking any walls in our shop, which is actually really nice. And seeing it in live, of course, the speaker, all the moving parts on the robot, being able to walk around it is really cool, especially for the design team that can go around and just make sure everything looks correct even as it's moving during autonomous. Similarly, we used the mock-up of our 2025 robot design to test some of our sequencing logic. This is just to make sure that all of the parts on the robot are moving the correct way so we don't break stuff on the real robot if we're just trying to debug it. So a lot of moving parts when we move the algae and the elevator up and down, the intake up and down, and there was a lot of complex stuff to make sure all of these states are in the right order. So making sure that we don't break anything on a real robot and that it works in sim before we put it on the real robot is really beneficial for our design team because they don't have to rebuild the whole freaking thing. Even without simulation, we can visualize the field at full scale. And this has, of course, amazing applications, especially at the start of the season when we're still getting familiar with the new field and how it looks. This is a video that we filmed the day that the 2025 game was released, and XR allowed us to walk around the field and get a sense of the scale for how the cages looked, how the reef looked, how the driver station looked, and how the robot looks relative to all of these things. And we could just walk around and see the field elements, the robots, and get an idea of that. Another use case from this season was that we set up field elements in our shop. Since we don't have a full field, we have to make sure to accommodate for all of the things that are happening in our shop. So we were in a rush, of course, to get stuff set up efficiently, and this could take multiple hours in previous years, but using XR, we just put the stuff, we used XR to overlay all the field elements onto our floor, and using this, we could measure the distances really fast, and we aligned everything in like 30 minutes when it would have taken multiple hours in seasons past. Of course, AdvantageXR also takes full advantage of the LiDAR sensors on modern iPhones and iPads, which just makes everything a lot more accurate when you're moving around the whole thing.
Okay, so now let's talk about what's next for AdvantageScope. So one of the big things that we're currently working on is integration with the 2027 control system, which is called System Core. The plan is that AdvantageScope is going to include deeper integration with the new control system in order to support on-robot development, which you can check the blog posts from FIRST with some more info about that. That'll be a major focus for us in the upcoming off-season, and we're really looking forward to the deeper integration there. We're also going to be focused on improving our contribution guidelines and documentation. We want to make it so that if there's a feature that you're interested in adding, we want to make that as easy as possible for you. And we also want to be more clear about two potential contributors about the types of changes we are more or less likely to accept. so that that whole process goes much more smoothly. That's something we're really going to be prioritizing in the next few months. So if there's stuff you're interested in adding during the off season, keep an eye out for that. Now, most of the new features in AdvantageScope are driven directly by user feedback. So we really do want to hear from you about how you use AdvantageScope, any issues you've had, things that could go more smoothly. And in order to do that, you can find us on GitHub. That's the best place to submit feature requests or bug reports. Both are appreciated. So we're still figuring out what the exact feature set is going to be next year, but that's very much going to be driven by whatever you all say would be helpful to you. Okay, so in summary, here's the stuff we talked about today. We went through how to get started with logging, how and why to use AdvantageScope, the value of merging data sources, and some stuff that's new and in the pipeline for AdvantageScope. Here are some links to some of the tools that we've talked about today. If you want to get in contact with us, the best way to do that is to email software@team6328.org. We really appreciate the time you've taken to listen to us today. And we have a few minutes for questions. As I said before, we'll be starting our next presentation at 11 o'clock sharp. So thank you very much.